Okay, according to the intermediate value theorem, this equation equals 6 has, and we're looking for a choice. So the intermediate value theorem tells us that the gist of it is basically this, is that if you have some function and for some x value, let's say here and here. So in this case, this is going to be our 1 and 2. So I'll call this just a and b. It's saying that if at this point we're at some height and at b we're at some other height, then if this function's continuous, then it must be that somewhere in between the graph will hit a height of something in between the heights of these two, right? So I'm not sure I said that very well, but the point is, if it's continuous, you can't jump over any values. If you somehow got from this height to this height, you must have gone through all of the heights in between. So this has nothing to do with solutions necessarily, although if we were looking for where it's equal to 0, if I change the x-axis to in between, you certainly can use that. But anyways, then what we want to notice is that when x is equal to 1, so if we substitute 1 in for x here, when we substitute x equals 1 in here, and we could just do this quickly in our calculator, we get an output of 2. So when x is 1, this is up at a height of 2. And when we substitute 2 in for the function, we again on our calculator we quickly see we get an output of 11 here. So the fact that the intermediate value theorem is basically telling us that somewhere in between this function must hit a value of 6 because it somehow went from 2 to 11. It's continuous because it's a polynomial. So somewhere in between there's some value, so say here, such that the function is equal to 6. So it's telling us that we have a solution in the interval between 1 and 2. So a solution to this equation, right? We're solving this equation. So I think actually now that I'm finishing up this problem, I'm realizing I probably misspoke here. So the solution is more the issue, not about a global maximum or a minimum.